Okay, Gary, morning. Can you hear me? Morning.
Yes, sir. Good
All
morning,
right,
sir.
morning. Today, I'm going to post a question on the chat. We did so last week we did elasticity. On Tuesday we worked on elasticity. So I'm going to put a um, a question. Okay, on the question is on the chart. So you are expected to find the Julie's elasticity of demand use the point elasticity formula. Yeah, can you see the question?
Yes, I can see it.
All right, so try and solve that. Let's see.
Okay.
Not midpoint, point, which is this for smaller changes.
Okay,
Okay,
sir.
not midpoint. Midpoint is where you add Q1 plus Q2 divided by 2. It's not that formula. The formula you are using is Q2 minus Q1 divided by Q1, then P2 minus P1 divided by P1. Okay.
Yes, okay.
So guys that are just coming in, morning, I put a question on the chart. Look at the chart. Let me see if you can see the question. I want you to find Julie's elasticity of demand using the point elasticity formula. Okay, find Julie's elasticity of demand using the point elasticity formula. So let me know if you've gotten the answer. You let me know. Okay. So what's the answer? What's the answer? Okay, guys, what did you get? Caracas, what's your answer? Fatima, Gary, what's the answer? Guys, I am waiting. You want me to make it your quiz?
Teacher, no. What is the question?
The question is on the chart. Did you check the chart?
I don't know how to check the chat.
Please check your chart. Gary, what's the question? What's the answer?
The first answer is
No,
3.375.
give me the total answer. What's the total answer that you have? What is Julie's elasticity of demand?
I'm getting there. I'm not there. Like I'm getting there now. I'm
Okay, I'm
not
waiting.
done.
Professor, I can't find the question.
Okay, let me post it in the chat again. Okay, I'm going to post it in the chat again.
Okay.
Check your chart. Have you seen it? Check the chart. Can you find the question in your chart? Fatima, have you seen the question?
Yes, Professor, thank you.
Okay. Yeah, Kayakers, have you seen the question in the chart?
Yes.
Okay, so I'm waiting. What's your answer?
My answer is 0.
0. So tell me, how did you arrive at 0? So tell me what you did. Gary, tell me what you did. For changes in quantity, what did you do?
I did 3.75.
First of all, tell me what the quantity is.
The quantity. The quantity 2 is 3.75. The quantity 1 is 3. I divide it by 2.
Wrong.
Wrong?
Wrong. Of course, wrong. Read the 1 second. Kayakers, what do you have?
I'm calculating, teacher.
Okay. So if you look at the question, it says yesterday, the price of envelopes. So that 3 that you are mentioning, that is the price. You could see the question. It says yesterday, the price of envelopes was $3 a box, and Julie was willing to buy 10 boxes. Today, the price has gone up to 3 points. So you can see dollars at the back. Of course, you should know that when you see dollars at the back of a question, or pounds, or any type of currency, of course, you should know that that means price. It says when the price has gone up to 3.75 a box, and Julie is now willing to buy 8 boxes. Okay, so what is your P1? Your P1 is $3 and your P2 is $3.75. What is your Q1 and your Q2? Your Q1 is 10 boxes and your Q2 is 8 boxes. Okay, Gary. So those 3 and 3.75 that you have there, those are your prices. Okay.
Okay, all right, sir.
Okay, so if you get that, try and solve that, you should be able to know what the answer is. Now, Kakes, what did you get? Fatima, what do you have?
Is it negative 0.8?
Good. The answer is 0.8. That is the answer. Okay. Because how would you solve it? I've mentioned Q1 and Q2, P1 and P2. You already know the formula, how to find using the point formula. That is Q2 minus Q1 divided by Q1, you multiply by 100. How do you find for price? P2 minus P1 divided by P1, you multiply by 100. Then divide Q by P. Then you'll be able to get your Jane's elasticity of demand. Okay. I think we have one more. We have one more before we go into okay. Let me post the question. So I posed the question. I said, Catherine advertises to sell cookies for $4 a dozen. She sells 50 dozen and decides that she can charge more. She raises the price to $6 a dozen and sells 40 dozen. What is the elasticity of demand? Assuming the elasticity of demand is constant. Take out this last part. Let me take, I'm coming. Leave this last part that says, assuming the elasticity of demand is constant, how many would she sell if the price is $10 a box? So leave that last part. Just focus on Catherine advertises to sell cookies for $4 a dozen. She sells 50 dozen and decides that she can charge more. She raises the price to $6 a dozen and sells $40. What is the elasticity of demand? Yeah, focus on that. Is the question clear? Is the question clear? Is it clear?
Yes.
Yes, sir.
All right. Okay, so find what is Catherine's elasticity of demand. Okay, so let's solve that. You have a few minutes. What do we have? What do we have? What's the answer? Fatima, Kayakes, Gary, what did you get?
Professor, I'm still doing it.
Tamam. Kayakes, what do you have? You guys should be done by now.
.4.
0.4. Was that what you
Yes.
got, Gary? Fatima, was that what you had?
Yes, Professor.
You had 0.4, right?
Yeah, negative 0.4.
Yeah. Negative. Let's see. Yeah. So you remember that I told you that whether you have a negative 0.4, you could also still write a 0.4. It doesn't really matter. Do you understand?
Yes.
Yeah. All right. So whether you write negative or you write 0.4, yeah, it's all still fine. All right. So let's go into today's, that's some exercises for you to be able to know how to do elasticity. You can use also, this same question can be used, for example, assuming I ask you to do that of midpoint formula. Okay, you know what to do, Q1 plus Q2 divided by 2, then you find your midpoint. Then when you want to find the changes in quantity, that would be Q2 minus Q1 divided by the midpoint of Q. You also do the same thing for P, and you find your price elasticity of demand, okay? So today, we're going to dive into risk, uncertainty, and choice. Risk, uncertainty, and choice, okay? We're going to dive into risk. Let's see, yes. Can you guys see my screen clearly?
Yes.
Yes? All right. So in the first two topics, we have assumed a certain world. That is the one in which the consequences of any choice made by the consumer were fully known before the choice was made. This is hardly the case in the real world. This topic would introduce the idea of uncertainty and risk and examine the implication of this consumer choice. So let's take a look at what uncertainty is. I'm sure if someone says, "Oh, this is uncertain," you are saying, "Oh, I'm not sure." Okay, uncertainty refers to situations in which many outcomes of a particular choice are possible, but the likelihood or probability of each outcome is unknown. So uncertainty is you take a step, but you are not sure of what the outcome would be. For example, you decide and say, "Oh, I'd like to go back to my country," but you are uncertain about the events that would happen in your country. Okay, so uncertainty is you take some steps, but you are not sure of what the outcome is. You don't know what the outcome is. You can't say categorically that this is what will happen. So how does it differ from risk? Okay, I said risk can only be measured accurately on the assumption that we all know the possible outcomes and the likelihood in bracket or probability of each outcome. Okay, so for risk, if you are taking a risk, you know that you might win, for example, or lose. You might make money or lose money. You might pass or you might fail. You might excel or you might not excel. So you are taking a risk, but you are sure of what the outcome will be, and the outcome usually comes in form of win or lose, um, or first or last, or first or second, or I mean, you know what the options are. For example, for an investor that is going to invest some money, if that investor wants to invest $10,000, for example, that investor knows that he might make money or he might lose money. That's a risk, but he knows what the outcome is. It's different from uncertainty in such a way that you invest money and you don't even know what is going to happen. Okay, so those are the differences between uncertainty and risk. Uncertainty is you take certain steps, you don't know what the outcome will be. Risk is you are taking certain steps and you know what the outcomes might be. It could be win or it could be lose. All right. You guys understand that? Do you understand?
Yes.
Yes, sir.
Okay, let's go on. I'll skip this part. So if you've taken, was it all the guys in class, you took 102 from me, right?
Yes.
Yeah.
Yes.
I know Gary took and Fatima. Yeah. So can you still remember what we did in class as regards risk aversion, risk neutral, and risk loving? Can you remember? Let me take it up. Can you remember when we talked about risk preferences, risk averse, risk neutral, and risk loving? Can you remember? Kaya, guess Gary, Fatima, can you remember? I'm waiting for your response. I want to know if you can remember or not.
Excuse me, Professor, can you repeat the question, please?
1 second. So, when we did principles of economics, we talked about risk preferences, which are risk loving, risk neutral, and what's the last one? Risk averse. Can you remember those risk preferences we talked about?
Are these the graphs one? The three graphs?
Yes, the three graphs, yes.
Yeah.
Okay, so I'll go through them again very briefly. So, preferences towards risk. Okay, there are things we've done, but we'll go through them because they are very important also in microeconomics. A person is described as risk averse if he or she prefers a situation in which a given income payoff is certain to a situation yielding the same expected value for income, but which involves uncertainty. Or risk aversion is the tendency of people to prefer outcomes with low uncertainty to those outcomes with high uncertainty.
I'm
Even
very
if,
sorry, Professor. I don't mean to interrupt you, but is the question that you're reading out put on the screen?
yeah, let me see. Can you see?
No,
Yeah,
I
yeah, yeah.
can't see the question.
No,
Yes.
it's not a question. Can you see
Oh,
my screen?
yes. Now it changed, but before it wasn't changed. That's why.
What was on the screen before?
It was written risk, uncertainty, and something else. I forgot.
Really?
Yeah.
Is that the same for you guys, Gary and kayakers? Did it just change now?
Yes, it
Yes.
changed now.
Yes.
Okay. All right. Okay, so let me so risk averse. A person is described as risk averse if he or she prefers a situation in which a given income payoff is certain to a situation yielding the same expected value for income, but which involves uncertainty. Or risk aversion is a tendency of people to prefer outcomes with low uncertainty to those outcomes with high uncertainty, even if the average outcome of the latter is equal or is equal to or higher in monetary value than the more certain outcome. Okay. In summary, it means a risk averse person is someone who does not love risk. Okay. The person does not love to take risk. Even if you say the person is going to make more money, with the money that he has, then he would not still want to take the risk. He prefers that little amount he has and he doesn't want to lose it whatsoever. So what does he do? He prefers to keep his money. So a risk averse person is someone who does not love to take risk. It's something we have discussed before. Okay, this is the graph of a risk averse person. A risk averse person has diminishing marginal utility of income. Okay, and you can see that where here the total utility curve flattens out. The total utility curve flattens out, and you can see that. Okay, so a risk neutral person is indifferent. Okay, meaning that between certain and uncertain outcomes with the same estimated value of income. So it's neither here or there. He can decide to take the risk and he can decide not to take the risk. Okay, he's going to have like the same utility. If he takes the risk of investing $10,000 and he makes, let's assume, $5,000, it will be as satisfied as if he doesn't take the risk and if he doesn't make $5,000. So we say the such an investor or such a person is in between, is indifferent. Okay, he can invest or he might decide not to invest. He doesn't lose anything. It's not his feelings as regards the two options is indifferent. He doesn't mind investing and he doesn't mind not investing. Okay, for risk neutrality, it arises due to constant marginal utility of income. With constant marginal utility of income, a risk neutral person obtains the same utility from certain income as an equal amount of income involving risk. Okay, so let's see what the graph looks like. Okay, a risk neutral person has constant marginal utility of income. A risk neutral person has constant marginal utility of income, and you can see that the total utility is
a straight line. Is a straight line. Okay. So is this clear up to this? Is this clear? Is this clear up to this stage?
Yes.
Okay, good. All right. Let's move on. We move to risk loving. A risk loving person, a preference for risk in which a person prefers risky income over guaranteed or certain income. A risk loving arises due to increasing marginal utility of income. A risk loving person prefers to undertake risk and is even willing to pay to do so. I'm sure this is clear to you. A risk loving person has increasing marginal utility of income and is someone who loves to take risk. Okay. And this is what the graph looks like. Okay. The total utility is carved out. Okay. You can see. Yeah. So we go to, can you also still remember when we did present value, future value, and net present value? Can you remember?
Yes.
Okay. So let me take out, what is the formula for the present value? What is the formula for the present value? What is the formula for present value? What is the
Future
formula?
value.
You said?
Future value
Okay.
over one.
Are you looking at your notes?
No.
Okay, so tell me, future value, yes,
Over one.
divided
By
by,
one.
You are not done. Future value divided by 1 plus future value divided by 1 plus R yes, raised to power what? Raised to power n. You guys can't remember. Okay, 1 plus future value. So for present value is future value divided by 1 plus R raised to power n. Okay, and this is it here. Future value divided by 1 plus R raised to power n. Okay, just it's something that I taught you guys. So if you can't remember, please go through your notes. Okay, so these are the, you already know what to do. Is this clear? Please look at your screen. Is this clear? Since I just taught you guys not too long, I want to know whether to go through this again or we should move on. Is this clear?
Yes.
Yes, it's clear.
It's clear. Okay, let's move on. Present value. You also still remember your net present value, right?
Yes.
Okay, good. Good. And you remember your future value. If present value equals future value divided by 1 plus R raised to power n, then future value equals present value into bracket 1 plus R raised to power n, okay? This should be clear. Let me just play you a something related to utility and risk preferences. then because we are going to have a calculation, so I have to yes, I'm coming. Let me
Let's take a look at the utility and risk preferences
can
for
you guys
different
get the
types of
video?
investors.
Yes?
You can have a risk-averse investor,
Okay.
and that person is going to exhibit diminishing marginal utility of wealth. That means that as their wealth increases, their utility or their satisfaction increases, but at a decreasing rate. So going from having $1 in wealth to $2 in wealth brings you more extra satisfaction or more extra utility than going from $20,000 to $20,001 in wealth. You can have a risk neutral investor. This is a person who exhibits constant marginal utility of wealth. This is the case where when you get a $1 increase in wealth, you get the same increase in utility. So going from $1 to $2 is the same as going from $100,000 to $100,001. You get the same increase in your utility or your satisfaction. And then you have the risk lover. The risk lover is a person who exhibits increasing marginal utility of wealth. This is the person who actually gets more utility as they get wealthier. So this person goes from having $1 to having $2. They actually get more utility if they go from $100,000 to $100,001. So let's take a look at an example. It might be easier to understand and explain this. So consider a gamble where an investor has a 50% chance of winning $50,000 and a 50% chance of winning $150,000. The expected dollar value of this gamble is just the expected value of these two possible outcomes. So 50% times 50,000 plus 50% times 150,000. So the expected dollar value of the gamble is $100,000. So if we look at a risk-averse investor, this blue line is their utility function. And so at each level of wealth, they have a certain level of utility or satisfaction. So at 50,000, they have a certain level of utility. At 100,000, they have a higher level of utility. At 150,000, they have an even higher level of utility. And you can see that going from 50 to 100 increased utility by this amount, but going from 100 to 150 increased utility by a smaller amount. That's the decreasing marginal utility of wealth. That is, the first $50,000 increase, or the increase from 50 to 100, gave them a greater jump in satisfaction than going from 100 to 150. Now, I've put in these numbers 50, 100, and 150 because they represent the gamble and the expected value of the gamble. So if you look at this red dashed line here, this shows us the utility they get from gambling. And in this case, because the expected value of the gamble is 100,000, we can draw up to this curve, or this dashed line, and draw across. This would be their level of utility. What we see is that it's lower than the 100,000 with certainty. So given a choice, this person would rather have 100,000 with certainty than taking the gamble of 50% chance of getting 50,000 or 50% chance of getting 150,000. So the utility from the certainty of 100,000 is greater than the expect or utility from taking the gamble, from the expected value of the 100,000. Okay, we can actually quantify this in a way, and let me show you another graph here. What this graph does is we've drawn across from this 100,000, okay, the expected value of the gamble, we've drawn across horizontally until we just hit the utility function. And here, let's say it's 90,000. So basically, this person, we call this the certainty equivalent, would rather have 90,000 with certainty, okay, or what gets the same utility of 90,000 with certainty as they do with 100,000 from the gamble of 50% chance of getting 50,000 or 50% chance of getting $150,000. So this person might be willing to pay $10,000 in order to assure themselves of getting 90,000. Okay, they don't want to take the gamble. They're not willing to take the risk. Okay, let's compare that to the risk neutral investor. They have a straight line utility function, and so you can see that because there's no curvature, no bowing, that the utility of the certain 100,000 is also the same as the utility of the expected value of the gamble. This is a person who doesn't really care about the risk that's involved. They only care about the expected value. The expected value is 100,000 with certainty. The expected value is $100,000 on the gamble. They don't care. They will take either. They're indifferent between the two. And then the final case is where you have somebody who's a risk lover. In the case of a risk lover, they exhibit this increasing marginal utility of wealth. So the curve goes this way. And what you can see is that the 100,000 with certainty actually gives them less utility than the expected $100,000 they get from taking the gamble. So this is the kind of person who wants to take the gamble. And there are examples of this, usually at lower levels of wealth, but people who play the lottery, the expected value is negative. People who go to the racetrack and bet on horses exhibit some risk-loving behavior. So this is the case where I'd rather take the gamble than the certain amount. Okay, I'd rather go to Las Vegas and take the chance of 50% chance that I lose $100 and 50% chance that I win $100 than to take the certainty of just doing nothing. And it's actually not 50-50. So these are people who would rather take the gamble than to take the certain amount. So they exhibit different kinds of behavior. And again, we see this example in certain kinds of behavior, but usually at smaller levels of wealth. So actually the utility function might be bowed upward this way, curving this way at low levels of wealth, and then showing diminishing marginal utility of wealth at higher levels of wealth. So this gives you an idea of why some people take a gamble and why some people don't. And in fact, if we sort of scroll back here to the risk-averse individual, this is why people buy insurance, because the expected value, the utility they get from the expected value isn't as good as the certainty. Okay, they'd rather pay this amount for insurance in order to assure that they'll get $90,000. Okay, so there's an argument in finance for things like insurance and why people need to be rewarded more and more for taking on extra risk.
Okay, that's just a little bit of summary for risk averse, risk neutral, and risk loving. Okay, so we've done utility and we've done risk preferences, right? But there is also a calculation under risk preferences, and I want you to pay very close attention. Okay, let me play that first. Then let me see, where's our slides? Yeah. Yeah. So this is it. I would let me play the video first because it's the same, the calculation is the same as the video, so that will, yeah, this one. Are you guys with me? I want to be sure are you guys with me? Can you hear me?
Yes.
Yes, okay, good.
Yes.
Yes.
For this calculation, please guys, pay very close attention. I'm coming. Let me. Okay, so I'm going to start it now. Pay very close attention to this calculation. It's the same as, yeah, it should be the same as what we have on the slide, all right? So when I explain it on the slide, if it's not clear, then you can then go back and watch it to practice it, all right? So let me do that now.
Hello everyone, my name is Iris France. 我叫林婉如. Today we're going to talk about expected utility. So economists use expected utility to describe your welfare under uncertainty. So for example, if you're buying a lottery, then there's a chance that you win. There is also a chance that you don't win. So it's under uncertainty. Or when you're trying to park at an unauthorized area, then there's a chance that you get towed and suffer a loss. But there's also a chance that nothing happens. So you can see there are a lot of situations under uncertainty. And we economists use expected utility to describe this kind of situation. So today we're going to talk about 3 kinds of risk preference: risk aversion, risk loving, and risk neutral. Now I'm going to give you the bottom line first, and then I'm going to explain what that means. So suppose you're given 2 options. One is that you can participate in a lottery with a half chance you're going to get $100, and with probability a half you're going to get nothing, so $0. Or you can get $50 for sure in your pocket and you can go home. So which one would you choose? Would you prefer to play the lottery, or would you prefer to have the $50 in your pocket? So suppose you choose the $50, then you are risk averse. Suppose you say you prefer to play the lottery with a half a chance to get $100 and a half a chance to get $0, then you are risk loving. Now if you say I'm neutral or I'm indifferent between the 2 options, then you are risk neutral. So let me explain what that means. So this is a lottery. You are going to get 100% chance. One means 100% chance to get $50. And you say you prefer that to the chance to win $100, and also with probability 50% you're going to get nothing. So that means the utility of $50 is higher than the expected utility of this lottery, which is a half times the utility of $100 plus a half times the utility of 0. So this one is bigger than that. Then you are risk averse and you prefer to have $50 in your pocket for sure. It is kind of similar to better one bird in hand than 2 birds in the forest, right? That's risk averse. So one example is that your utility is equal to the square root of x. So we can plug in the payoff of $50. So what is utility of $50 for sure? And after you calculate that, you take the square root of 50, then you get 7.07. Then what is the utility, the expected utility of this lottery? there will be a half times the utility of $100 plus a half times the utility of $0. Then you plug in this utility function, and after you calculate that, you get 5. So clearly 7.07 is higher than 5. And that's the reason why you prefer to have $50 for sure. And if you draw the utility curve, then you can see this is a utility function. So that would be, this would be $50, $100. And if you plug in $50 into the utility function, you get 7.07. And the expected utility of that lottery will be a half times 10 plus a half times 0, and that gives you 5. So here, you can see the letter L, that stands the expected utility of that lottery. So that's only 5. 5 is less than 7.07, so you choose to have $50 in your pocket for sure. Now we're going to move on to risk loving. So risk loving, if you remember, you choose to play the lottery that gives you a chance, a 50% chance to win $100 rather than $50 for sure. So that tells me, hey, your expected utility of that lottery is higher than the utility of $50 for sure. So one example is expected utility. So the utility of x is equal to x squared. Then you can plug in numbers. The utility of $50 for sure is equal to x squared. So 50 squared, that's equal to 2,500. And what is the expected utility of the lottery? There will be a half times the utility of $100 plus a half times the utility of $0. And if you plug in numbers, $100 squared is equal to 10,000 times a half plus a half times 0, because the utility of $0 is still 0. And that expected utility is 5,000. Now clearly 5,000 is higher than 2,500, so you prefer to play the lottery. And graphically, you can see that this is a utility function, and the utility of $50 for sure is here. So $50, you plug in the utility function, that gives you 2,500. But what is the expected utility of the lottery? So you do a half times 10,000, that's the utility from $100, and plus a half times 0, because 0 squared is still 0. And that gives you 5,000. So this is the expected utility of the lottery, and that's higher than the utility of $50 for sure. So you can see that that's risk loving. And finally, if you're telling me I am neutral between $50 for sure and playing the lottery, then you are risk neutral. That means the utility of $50 is exactly the same as expected utility of that lottery. So our example is ux is equal to 1/10 times x, but anything that is linear will work. So you can see that utility of $50 is equal to 50 divided by 10, that gives you 5. And the expected utility of playing the lottery is a half times the utility of 100, which gives you 100 divided by 10, that's 10. Plus a half times the utility of $0, that's 0. And that gives you 5. So you can see 5 is equal to 5, and therefore you are neutral between having $50 for sure or playing the lottery. So now you will ask, what exactly is our risk preference? Are we risk loving or are we risk averse? Well, you can be both at the same time. The fact that you're buying a lottery shows me that you are risk loving, but the fact that you're buying insurance shows me that you are risk averse. So you can be risk averse and risk loving at the same time, depending on the situation. So I hope this helps, and I'll see you next time.
Okay, guys, so what we'll do is we'll go on our 10 minutes break. Okay, we'll go on our 10 minutes break, and when we get back, what I will do is I'm going to refresh this video. I'm going to play it again, then I'll now go ahead and explain. Okay, is that okay, guys? Is that okay?
Yes.
All right,
Yes, sir, it's
so you
okay.
can go on your 10 minutes. We'll be back 10:10. Okay, we're back. Is everybody in class? Is everybody in class?
Yes.
Yes.
Let's run the video back again.
Ανακάλυψε το μέλλον των ηλεκτρονικών πληρωμών για σένα και την επιχείρησή σου σε μερικά κλικς. Κατέβασε την
Hello everyone, my name is Iris France. 我叫林婉如. Today we're going to talk about expected utility. So economists use expected utility to describe your welfare under uncertainty. So for example, if you're buying a lottery, then there's a chance that you win. There is also a chance that you don't win. So it's under uncertainty. Or when you're trying to park at an authorized area, then there's a chance that you get towed and suffer a loss. But there's also a chance that nothing happens. So you can see there are a lot of situations under uncertainty. And we economists use expected utility to describe this kind of situation. So today we're going to talk about 3 kinds of risk preference: risk aversion, risk loving, and risk neutral. Now I'm going to give you the bottom line first, and then I'm going to explain what that means. So suppose you're given 2 options. One is that you can participate in a lottery with a half chance you're going to get $100, and with probability a half you're going to get nothing, so $0. Or you can get $50 for sure in your pocket and you can go home. So which one would you choose? Would you prefer to play the lottery, or would you prefer to have the $50 in your pocket? So suppose you choose the $50, then you are risk averse. Suppose you say you prefer to play the lottery with a half a chance to get $100 and a half a chance to get $0, then you are risk loving. Now if you say I'm neutral or I'm indifferent between the 2 options, then you are risk neutral. So let me explain what that means. So this is a lottery. You are going to get 100% chance. One means 100% chance to get $50. And you say you prefer that to the chance to win $100, and also with probability 50% you're going to get nothing. So that means the utility of $50 is higher than the expected utility of this lottery, which is a half times the utility of $100 plus a half times the utility of 0. So this one is bigger than that. Then you are risk averse and you prefer to have $50 in your pocket for sure. It is kind of similar to better 1 bird in hand than 2 birds in the forest, right? That's risk averse. So one example is that your utility is equal to the square root of x. So we can plug in the payoff of $50. So what is the utility of $50 for sure? And after you calculate that, you take the square root of 50, then you get 7.07. Then what is the utility, the expected utility of this lottery? There will be a half times the utility of $100 plus a half times the utility of $0. Then you plug in this utility function, and after you calculate that, you get 5. So clearly 7.07 is higher than 5. And that's the reason why you prefer to have $50 for sure. And if you draw the utility curve, then you can see this is a utility function. So that would be, this would be $50, $100. And if you plug in $50 into the utility function, you get 7.07. And the expected utility of that lottery will be a half times 10 plus a half times 0, and that gives you 5. So here you can see the letter L, that stands the expected utility of that lottery. So that's only 5. 5 is less than 7.07, so you choose to have $50 in your pocket for sure. Now we're going to move on to risk loving. So risk loving, if you remember, you choose to play the lottery that gives you a chance, a 50% chance to win $100 rather than $50 for sure. So that tells me, hey, your expected utility of that lottery is higher than the utility of $50 for sure. So one example is expected utility. So the utility of x is equal to x squared. Then you can plug in numbers. The utility of $50 for sure is equal to x squared. So 50 squared, that's equal to 2,500. And what is the expected utility of the lottery? There will be a half times the utility of $100 plus a half times the utility of $0. And if you plug in numbers, $100 squared is equal to 10,000 times a half plus a half times 0 because the utility of $0 is still 0. And that expected utility is 5,000. Now clearly 5,000 is higher than 2,500, so you prefer to play the lottery. And graphically, you can see that this is a utility function. And the utility of $50 for sure is here. So $50, you plug in the utility function that gives you 2,500. But what is the expected utility of the lottery? So you do a half times 10,000. That's the utility from $100. And plus a half times 0, because 0 squared is still 0. And that gives you 5,000. So this is the expected utility of the lottery, and that's higher than the utility of $50 for sure. So you can see that that's risk loving. And finally, if you're telling me I am neutral between $50 for sure and playing the lottery, then you are risk neutral. That means the utility of $50 is exactly the same as expected utility of that lottery. So our example is ux is equal to 1 over 10 times x, but anything that is linear will work. So you can see that utility of $50 is equal to 50 divided by 10, that gives you 5. And the expected utility of playing the lottery is a half times the utility of 100, which gives you 100 divided by 10, that's 10. Plus a half times the utility of $0, that's 0. And that gives you 5. So you can see 5 is equal to 5, and therefore you are neutral between having $50 for sure or playing the lottery. So now you will ask, what exactly is our risk preference? Are we risk loving or are we risk averse? Well, you can be both at the same time. The fact that you're buying a lottery shows me that you are risk loving, but the fact that you're buying insurance shows me that you are risk averse. So you can be risk averse and risk loving at the same time, depending on the situation. So I hope this helps, and I'll see you next time.
So yeah, so let me just go through that video. I'm sure it must be almost clear, but let's go through it together. Now, the major question is that you have an opportunity to play lottery, okay? And if you play that lottery, you have 50% chance of winning $100. Okay, this half means 50%. Okay, half, you have a 50% chance of winning $100. And what other chance do you have? You also have a 50% not winning anything. That's what this means. Half, comma 100, or half, $0. All right, is this clear, guys? Is this clear?
Yes.
Okay.
Yes.
Now, if you don't play the lottery, so one option is play the lottery, win $100, or don't win anything at all. The other option is, if you decide not to play the lottery, you have a guarantee of $50. Okay, you have an expected value of $50. Okay, play the lottery and win $100, or you lose the $100, or don't play the lottery at all. If you decide not to play the lottery, we are going to give you $50. Okay, that's what this means. It says expected value $50. If you choose the $50, you are risk averse. So it's either you play the lottery or you do not play the lottery. If you play the lottery, you are someone who loves risk, or you could also be risk neutral. If you don't play the lottery, then you are someone, if you don't play the lottery and you decide to take the $50, okay, instead of playing the lottery, then you are risk averse, okay? So is that clear? Are those two assertions, are they clear? Are they clear? Before we move on. So play the lottery, win $100, 50% chance of winning $100 or 50% chance of losing everything. Okay, that's someone who loves risk, a risk loving. Or, oh, I'm not going to play the lottery, but I have a guaranteed sum, an expected value of $50. Okay, that means you are a risk averse person. And if you are someone who is between risk neutral and risk loving, you are in between, either playing the lottery or not playing the lottery, then you are a risk neutral person. Are these three assertions, are they clear? Are they clear, guys?
Yes.
Okay, Gary, is it clear? Fatima, is it clear? Mesit, is it clear?
Yes, it's clear.
Yes.
Okay.
Yeah,
All right.
yeah, doctor.
So now let's start with risk averse. We've already said that a risk averse person is someone who does not love to take risks. Remember, if the person does not love to take risk, it means that he is going to have 100% of the $50. He is going to have everything. This one that you have here, meaning that he is going to have 100% of the money. Okay, he's going to have the full $50, as opposed to when you say half. Okay, meaning half means 50% chance of $100 or 50% chance of $0. So this first part that says, you could see that under risk averse, you see 1, $50. What that means is that, we are doing risk averse. What that means is that a risk averse person will not, he would not love to take risk. And so he will prefer the 100, he will prefer $50. He will prefer to take all the $50, which means 100%. He has full chance of 100% of the money. Okay, is that part clear? So that's why you have 1, $50. Is that clear? Is that clear? Is that first part clear? 1, $50. What that means? That means that a risk averse person will have full percentage. It's just 100% of is $50. Is that part clear?
Yes.
Good. So let's look at the right-hand side. You could see something like greater than, something like the greater than sign. So that is saying, that left part is saying that a risk averse person would take $50 as opposed to playing the lottery and getting $100, or playing the lottery and losing all the $100. That's why you have half, $100, half, $0. That first half, $100 simply means he has a 50% chance of winning $100, and the other half, 0, means he has a 50% chance of losing everything. If you toss a coin, for example, you have a 50% chance of head, and you also have a 50% chance of tail. That's what this is trying to refer to. A 50% chance of winning the $100, a 50% chance of $100. Is that clear? Can we move ahead? So you understand that first part? Yeah?
Yes.
Okay. Now, so how do we solve it? This, you see here, you have utility. U means utility. Utility of $50 is greater than half of utility of 100 plus half of utility of 0. Is this this first equation is we are simplifying it. That's what you have in this second equation. Okay, meaning that a risk-averse person will go for $50 as opposed to going for playing the gamble. Remember this equation, u of x equals square root of x. Please remember, for risk averse, you need that equation, u of x. Let me go to the chart. Remember u of x remember u of x. There's no square root here, but let me just write square root of x. Okay, remember that formula. I mean, I'm just writing the square root out because I can't seem to find at the moment, I can't seem to find square root on my computer. Okay, so remember that you will need that to be able to arrive at the solution for risk averse. Okay, so what is utility of x? So what we are trying to do is we are going to use this utility of x equals root of x to solve for both sides. And what are those both sides? The first one is utility of $50, and the second one is half utility of 100 plus half utility of 0. Is that clear, guys? Is it clear? Is it clear?
Yes.
Okay. All right. Fatima, is it clear?
Yes, Professor.
All right. So the first one is utility of 50. Okay. Utility of 50 equals square root of 50. I'm just picking this utility of 50, the one on the left-hand side. Just insert it into this equation. U of x equals utility of square root of x. So on the left-hand side, you have utility of 50 equals the square root of 50. Okay? And you then have utility of 50 equals, if you find, can you find on your phone or on your computer, what is the square root of 50? What is the square root of 50? Check it on your phone and let me know.
7.07.
7.07. Okay, so just type on your calculator or your phone, the screen, you find 7.07. Okay, so if you go for the $50, your utility that you're going to have is 7.07. Now let's go for the other side. What if you decide to play the lottery? Okay, here you see half utility of 100 plus half utility of 0. So what do you need to do? Remember that I said this equation, utility of x equals square root of x, right? So half, you just need to square 100 and you need to square 0. But what is the square root of 0? What will it give you? What is the square root of 0? What will it give you? You would have, the other side is cancelled, where you have 0. You cancel all that because, of course, it's going to give you 0. The one on the left-hand side is half square root of 100. And the square root of 100 is 10. 10 divided by 2 equals 5. So utility of playing the lottery is 5. Utility of taking $50 of not playing the lottery is 7.07. Which one is higher? Is it 7.07 or 5?
7.07.
So if you have utility of 57.07 is greater than 5, then what that tells you is this is risk averse. Okay, because risk averse will take $50 as opposed playing the lottery. Okay, so this is a risk averse, and this is the graph. Okay, this is the graph here. And in this graph, you can also see that 7.07 is greater than 5. 7.07 is greater than 5. So let's go to risk loving. Who can explain the risk loving for me? It's right there on your screen, but I want to see who can explain it. Who can explain the risk loving? Who can explain the risk loving for us? How did we arrive at starting from the first half of 100 semicolon or half of $0? Who can explain it? Gary, can you explain it?
No, sir. I'm a little bit confused. I'm a little bit lost.
Okay, tell me what where are you lost? Tell me.
The first one, the risk
The risk averse. Okay,
yeah.
tell me which area are you lost in the risk averse?
When you get like the first part,
Okay.
I want to know how did you get the 50
Okay.
at the dollar?
How did I get to $50, right?
Yeah.
Let me answer that first. Just hold on. Don't. The $50 is in the question. And what is the question? The question is that, for example, Gary, I give you have two options. The option is you can either play the lottery or you should not play the lottery. Okay, those are the two options. Play the lottery or do not play the lottery. If you don't play the lottery, I am going to give you $50. Okay, so that's where you see where I got that $50. And where you can see $1, $50 simply means you have 100% of the $50. You are not losing anything. Okay, that's why you have $1, $50. Simply means Gary is going to have 100% of the $50. I'm giving you everything. You are not losing anything. Okay, so that's how we got the $50. Is that clear?
Yes,
Is that
sir.
clear, Gary? Yeah. So from the other side, I'm saying, so the first side is not playing the lottery. And if you don't play the lottery, I'm going to give you $50. Okay, we've taken care of that. And the other side is, I say, Gary, okay, if you decide to play the lottery, then you should know that you have a 50% chance of winning $100, and you also have a 50% chance of not winning anything. That's where you have 0. So it's either you win $100, you have 50% chance of winning $100, or you have 50% chance of winning $0. Why you have half there is half, 50% is half of 1. So you would have 50% chance of playing and winning your whole $100, and you also have 50% chance, which is half, of winning $0. Okay? Is that part clear? Is that part clear, Gary?
Yes, sir.
So remember the formula I asked you to take note of. Utility of x equals your square root of x. You just need to plug in both sides into this equation. So if you plug in 50, utility of 50 equals square root of 50. So that means if I decide to give Gary the $50, then what will his utility be? That's square root of 50, that's 7.07. If Gary decides to play the lottery, that will be half square root of 100 plus half square root of 0. What you are going to have is 5. So utility of 50, if I give you the $50, is greater than if you play the lottery, then you are a risk-averse person. Gary, is that clear?
Yes, sir.
Okay, so with the same analogy, can you explain risk-loving? With the same analysis I just made as regards $50 giving you $50 if you don't play the lottery, and if you play the lottery, you win $100 or you lose everything. Can you explain risk-loving with that same analysis? So kayakers, can you explain? Can you explain kayakers? I'm waiting. Yes or no?
No, teacher.
You can't explain. Fatima, can you explain? Fatima, can you explain? Gary, can you explain it? Based on what I just explained to you. Gary, can you explain based on what I just explained to you? Explain risk-loving the same way I explain risk-averse, but this time around, you should know that you would prefer to take the risk than you prefer to take the risk than taking $50. Okay, so what this means is that half, that's the one on the left hand side is the lottery. I'm sure you know that right now. It will be greater than not playing. It will be greater than not playing the lottery, which is $50. What that risk-loving simply means, Gary has decided to say, oh, I'm going to go for the lottery instead of not playing the lottery. Okay, so therefore, remember this equation. Utility of x equals x squared. Please remember that. The first one for risk averse is utility of x equals square root of x. Guys, please pay close attention. If it's not clear to you, go and watch that video. Okay? And if it is not clear to you, you try and come and see me in the office. But it should be very clear. The first part is u of x equals square root of x. That's the equation for risk averse. The second part is for risk-loving is u of x equals x squared. You need that to be able to arrive at your values, whether it is okay to play the lottery or whether it is okay not to play the lottery. So if it is okay to play the lottery, what do you need to do? Just plug in, for example, 50 squared. What does 50 squared give you on your calculator? What does 50 squared give you on your calculator? What does 50 squared, what does it give you on your calculator?
2,500.
2,500. Okay, so just for risk-loving, just plug 50. That's your utility of x. So utility of 50 equals 50 squared. That's 2,500. Now, do the same thing for if you decide to play the lottery. If you decide to play the lottery, of course, you know that already. 5 equals utility of 100 plus 5 utility of 0. Okay? What do you need to do to the 100? You square it. What do you need to do to the 0? You square it. But use the one on the right-hand side. Half equals half into bracket 0 squared. That one takes up because 0 is going to cancel everything. And 100 squared is 10,000. 10,000 divided by 2 is 5,000. Now look at utility of $50 as opposed to utility of when you play the lottery. Which value is higher? Which value is higher? Is it that of playing the lottery or that of taking the $50? Which value is higher? Tell me which value is higher. Guys, I need you to respond. Is it the value of taking the $50 or is it the value of playing the lottery?
The value of playing the lottery.
The value of playing the lottery. That means that 5,000 is greater than 2,500. So that shows you that that investor or that individual is risk loving. And you can also see that in the graph. For example, in the graph, where did we get 10,000? 10,000 is 100 squared. Okay. And if you trace it down where we have 100. Okay. Square root of 10,000 is 100. And you can see the graph is for risk loving. It's upward sloping. You can see that. Okay. Curved, but it's more like going upwards. Okay, and you can see here also that on this graph, that 5,000 is greater than 2,500. So this person is risk loving. Now, what about risk neutral? Who wants to explain that to me? For risk neutral, how are we going to explain risk neutral? How are we going to explain risk neutral? Who wants to explain? I'm waiting, guys. Who wants to explain to us for risk neutral? How did we arrive at that? Explain it the same way I explained the first two. Maybe I should make it your quiz. That's what I will do. I'll make it your quiz for 5 marks. If nobody answers me, that will be five marks of your grade. Who wants to explain to me? Kayakers, can you explain it? Mesit, can you explain it?
I think, doctor, risk is same every level.
Good. Okay.
We call it neutral.
Okay.
Take every step take 10%. We take
this one instead of 10%. No, yeah. Take a look at this.
Yeah, to $5 to $50 to $10 to $100 we take. So neutral risk.
So yeah. So for
10%
neutral,
each level.
Yeah. So not 10%. Take a look at. Good try. I'm sure that's Mesit, right? Yeah, that's Mesit. Okay. Now, neutral simply means that you are indifferent. Okay, and you can see the sign. That sign is $1.50 is indifferent from half as $100 and half as a 0. So that means that you can either take the $50 without playing the lottery, or you can either play the lottery without taking the $50. You are indifferent. So just like risk averse, I told you pay attention to utility of x equals square root of x. For risk loving, pay attention to utility of x equals x squared. What should you pay attention to for risk neutral? What should you pay attention to in risk neutral?
Utility of x equal 1/10.
You are not done? Utility of x equals 1 over 10, okay?
Multiply by x.
Multiplied by x. Because you need all those equations, you need them to be able to arrive at your answer. Without those equations, you can't arrive at the values for the utility of if you play the lottery or utility of if you don't play the lottery. Okay, so remember, for risk averse, you need this equation. Utility of x equals square root of x. For risk loving, you need this equation. Utility of x equals x squared. For risk neutral, you need this equation. Utility of x equals 1 over 10 times x. You already know what x is. X is either 50 or x is half into bracket 100 plus half into bracket 0. That is what x is. Okay, so let's go. For 50, x equals 50, you see, utility of 50 equals 1 over 10 times 50. So you have 5. Okay, now plug in the same thing to the values if you play the lottery. That will be half utility of 100 plus half utility of 0. So half into bracket 10, because if you divide 1 over 10 times 100, it will give you 10. Then half into bracket 1 over 10 times 0, you know, that will give you 0, so you don't need that. Okay, so what do? That's half times 10. So this means half times 10. That's what you have here. Then that would be 5. You could see the utility of if you play the lottery is as good as utility of if you don't play the lottery. You have the same, you are indifferent. What that means is that if whether you play the lottery or whether you don't play the lottery, you will still get the same satisfaction from both. And you can see the graph, 10, 100, 5, and 50. Okay. You might need to practice it, by the way. So it's not, you might need to practice it, but most importantly, you would need these equations. Utility of x equals square root of x, utility of x equals x squared, and utility of x equals 1 over 10 times x. You need those equations to be able to arrive at the final answers. And that will help you to know whether they are risk loving, whether they are risk neutral, or whether they are risk averse. Okay. Please, do we have questions as regards this? Questions? I'm waiting for your questions. Do we have questions? So if I give you a question now, that means that you should be able to solve it, right? If you don't have questions, it means if I give you a question as regards expected utility, okay, and risk averse, risk loving, and risk neutral, you should be able to solve it. Am I correct? Just let me know if I'm correct. If I give you a question regarding this, after you practice very well, will you be able to solve it?
Teacher, I have a question.
Please write on.
The last sentence, when there is half, 1 over 2, open the bracket 10.
Yeah,
The
that
10
means, yeah, 1 over 2 times 10. That's what it means. Do you understand?
The 10, how will we get 10?
Okay, 10 is 1 over 10. Look at this equation. Utility of x equals 1 over 10 times x. So plug in 1 over 10 times 100. See this 100. If you play the lottery, you have 50% chance of taking $100. So 1 over 10 times 100. Kayakers, what would you have? If you have 1 over 10 times 100, what would you have?
10.
10. So that's where we get the 10. Is that clear?
Yes, it's clear.
Okay. So that's where we have our 10. If 1 over 10 times 100, you have our 10. And the other part, 1 over 10 times 0, you have 0. Okay. All right. So if there are no other questions, does anybody have any question? Okay. If there are no other questions, what we'll do now then is we'll take our 10 minutes break. And when we come back, we are going to take a look at the theory of production. You can take your 10 minutes break. When we get back, we'll do theory of production.
Okay, guys, I'll start by playing just to give you an introduction on production function, okay?
You will hear the term production function thrown around in economics circles, and it might seem a little intimidating and a little mathy at first, but as you're about to see, it's a fairly basic idea. It's this idea that you could have these various inputs. Let's call this input number 1, and then you have input number 2, and you can keep going. And then you put them in, their inputs, into some type of process, and then that function, let's just call that f, that's going to describe how much output you can get given that input. We can also describe it a little bit more mathematically. Those of you who remember your Algebra 2 might recognize this, where we could say the output, it's often used the letter Q in economic circle, it's going to be a function, it's going to be a function of the various inputs. So I'll put input number 1, input number 2, and you could have as many inputs as is necessary to produce that good. And these inputs, if you wanted to categorize them, these are the classic factors of production that we would have talked about before. These would be your land, labor, capital, and entrepreneurship. And it doesn't have to be all of them, but each of these inputs would likely be factored as one of these. Now, this might still seem very abstract and very mathy. So to make things very tangible, let's give a tangible example. Let's say that we're trying to make a bread toasting operation. So what we need to do is we take bread, we stick it in a toaster, and then once it's toast, we're done. And so what are our inputs there? Well, you're definitely going to need some bread. So let me draw some bread right over here, my best attempt at drawing bread. So that right over there, that is bread. You could call that input number 1. Now you're also going to need a toaster, at least one toaster, or toasters, I should say. And let's say the toasters that we use for this operation, they can toast 4 pieces of bread at a time. And it takes 10 minutes to do that. 4 slices in 10 minutes. Now you might say, well, aren't those going to be all of our inputs? But then the obvious question is that bread isn't just going to jump into the toaster on its own and then jump back out. Needs to be some labor to operate this operation. So we're going to need some toaster operators. And let's say that they can process 1 slice per minute. 1 slice per minute. I know many of y'all are thinking that you could do better than that, but try to do it all day. 1 slice per minute. Now, based on this, if these are really all of the 3 inputs into producing the output, toasted piece of bread, we could try to construct a production function here. So let's do that. So let's say the output is going to be the number of slices of toasted bread, and it's going to be equal to, and I'm going to write this as, well, I'm going to make our production function as being the minimum of several values. And what you're going to see is going to be based on what's going to be our rate limiting factor. And I don't want to get too much in the weeds with you on this, but just to help us understand. So it's going to be the minimum of, well, the amount of bread you have, so slices of bread, And why does that make sense? Well, the amount of toasted bread you can produce is always going to be limited by the amount of untoasted bread that you put into your process. If you only have 60 that's going in per hour here, well, then you can only produce a maximum of 60 right over here. And this is going to be per hour. So this is going to be the slices of bread per hour. Now our other input, how much toast can one toaster toast in 1 hour? Well, if they do 4 slices in 10 minutes, we'll multiply that times 6 to get to an hour. That's going to be 24 slices per hour. So we could do 24 times the number of toasters times the toasters. And then last but not least, how much bread or how many slices can one person process per hour? Well, it's going to be 60 slices per hour. So we'll do 60 times, let's call them workers. I was going to call them toasters, but we are already using that for the equipment, times the number of workers. And so it's worth, at this point, just pause the video and really process what's going on. What are the inputs here and what are the outputs? Well, the inputs are right over here. The number of slices of bread per hour, the number of toasters we have at our disposal, the number of workers. Toasters you could view as capital, workers you could view as labor. And now another interesting thing to think about, and we will talk a lot about this in economics, is what's going on in the long run and the short run. And production functions are useful for thinking about the long run and the short run because the short run is defined. The short run is defined as the situation in which at least one of your inputs is fixed. Let me write this down. At least one input is fixed. Now, what does that mean in our bread toasting example right over here? Well, let's just say that it's very easy to get slices of bread. If we have the capacity and we want to produce more bread, the slices of bread are, let's say it's just never our rate limiting factor. So that part isn't fixed. But to get a new toaster, let's say these are special toasters and you got to order them and it takes a month. So let's say that there's a 1 month lead time on this input. 1 month lead time. And let's say for workers, there's just not a line of people ready to toast toast. You have to put a job posting out there and you're going to have to interview people. And so let's say that it takes 2 weeks to hire someone. So 2 weeks to hire. Or I guess you could also say 2 weeks to hire or to fire someone if you want to reduce capacity. And let's say it takes 1 month to either get a toaster or to remove a toaster. Well, in that case, the short run in this situation is a time period where at least one of the inputs is fixed. So pause this video and think about what would be the short run in our situation. Well, the short run in our situation, the number of toasters we're going to have is going to be fixed for at least a month. So our short run in this situation is up to a month. So up to a month. And then the other side of it, what would the long run be? Well, in the long run, by definition, none of your inputs are fixed. You can change the number you have of any of these things. So our long run is going to be greater than 1 month in this example. Now, it's really worth noting that was just for this example. If we were talking about some type of automobile factory and the output is the number of automobiles produced per day or per month, and then you have all these inputs, you would have your metal, you would have your labor, and then you would have the equipment for the factory itself. Well, there, the long run, it might take another year or even 2 years or 5 years to build a factory. In that case, the long run would be the time period greater than amount it takes to build another factory. Usually capital is the thing that is most fixed for the longest period of time, and that's why I made it hard for us to get our toasters. So I will leave you there. This is just an introduction to the idea of a production function, but hopefully with our bread toasting example, it is not so intimidating.
Okay. Now let's get the ball rolling. Yes. Okay. I'm going to go through with you with the theory of production. Okay. When we say production, what does it mean? Production is concerned with the supply side of the market. Okay, we've done demand, okay, which has to do with consumption of goods and services. And this time around, we're moving to the production of those goods and services. You remember that in the beginning, I was trying to explain that what is, for example, microeconomics. And I said, microeconomics deals with how individuals and firms allocate scarce resources. So individuals are the ones who consume goods and services, while the firms are the ones who produce those goods and services. And under consumption, we've talked about demand, we've talked about market demand, we've talked about elasticity, we've talked about utility, risk, being risk averse. We've also talked about one more that I remembered now, indifference curves, budget line. These are majorly about how individuals and consumption of goods and services, all right? But now we are stepping to the firms. We are moving rightward to the on the other side of the fence, which is to the firms, all right? So, and that's why I said production is concerned with the supply side of the market. Production is concerned with the supply side of the market. Production is an activity of transforming inputs into outputs. Okay, inputs are resources used in the production process, and an output is any good or service that comes out of the production process. So, for example, if you want to produce a book, for example, a book. To produce a book, what do you need? You need maybe workers, you need the papers, you need printing machines. Those resources that you need that can enable you to produce a book, which is the output, those are the inputs. So all the resources you need to be able to produce a book, such as that I just mentioned, a normal book, okay? All the resources you need to produce any given good or service is regarded as inputs, okay? While the output is the final product. A shoe is an output. The slippers, the glasses, the pen, the phone, those are outputs. But it took some equipment to be able to produce them. The rate at which a given quantity of inputs can be transformed into output is governed by what we call the laws of production. The laws of production are also called the laws of returns and the theory of production. Sorry, give me a second. Sorry. All right. So the laws of production are also called the laws of returns or the theory of production. So we have the short-run laws of production and the long-run laws of production. Okay? The short-run laws are called laws of variable proportion, while the long-run laws are referred to laws of returns to scale. Okay? We have the short-run laws of production, the long-run laws. We have the short-run laws of production and long-run laws. The short-run laws are called laws of variable proportion, while the long-run laws are referred to laws of returns to scale. The law of variable proportion, also known as the law of diminishing returns, is an economic principle that states as more units of a variable input are added, the additional output produced per unit of the variable input will eventually decrease. Diminishing marginal returns arise from the fact that more and more workers are using the same capital in the same space. As more workers are added, there is less and less for the additional workers to do that is productive. For example, if Campus Sweaters hires a third worker, output increases but not as much as it did when it hired the second worker. In this case, after 2 workers are hired, all the gains from specialization and division of labor have been exhausted. By hiring a third worker, the factory produces more sweaters, but the equipment is being operated closer to its limit. There are even times when the third worker has nothing to do because the machines are running without the need for further attention. Hiring more and more workers continues to increase output, but by successively smaller amount. This passage, this paragraph I just read, explains what is called law of diminishing marginal returns. In a more simplistic explanation, what the law of diminishing marginal returns mean is that if you hire more workers, for example, if you have a firm or an organization and you keep hiring more workers, you keep putting in more labor, while the number of computers are fixed. The number of computers are fixed simply means that you are not adding more computers. What do you think would eventually happen? What will eventually happen is that the output you will get from additional workers that you are going to be employing will diminish. Okay, will diminish simply means there will be at times where the number of people, the additional people that you have employed, they wouldn't have anything to do. Why? Because capital is fixed. Okay, because capital is fixed. So, sorry for that. So the law of diminishing marginal returns is trying to state that as you employ more labor and capital is fixed, the output from the additional labor will eventually diminish. The output that you get from the additional labor will eventually diminish. Okay, so those resources that you need to produce those goods and services, what are they called? They are called the factors of production. They are called the factors of production. And what are these factors, or what are these inputs? Land, labor, capital, raw materials, entrepreneurship, technology, and time. Let me state that again. Land, labor, capital, raw materials, entrepreneurship, technology, and time. Okay, those are the factors of production, more like, and the inputs you need to be able to produce certain goods and services. Okay, let's write on. So we move to the production function. So guys, is that clear so far? So you know the laws of production can be short run or long run. Short run is also called law of variable proportion. Long run laws are laws of returns to scale. Under the short run laws, I didn't mention that. You remember the video that you played? You need the factors of production, input, and resources to produce good or service. In the short run, labor varies while capital is fixed. So it means that some of the resources you can easily employ more, and while some of the resources you might not be able to get some more easily in the short run. Okay. However, in terms of long run, all factors of production varies. You can change anything you want to change in the long run. Okay, that's the major difference. In the short run, you have fixed and variable inputs or materials or factors of production. In the long run, all your factors of production varies. In the long run, all the factors of production varies in such a way that you can change them anytime you want to change them. Okay, so we move to production function. So production function is simply the mathematical relationship between input and output. Just the equation, that's all. Okay, in the definition of production, we say production has to do with the transformation of input into output. So the production function shows the mathematical relationship between those inputs and outputs. And you can see here in our graph here where you have output equals as a function of capital and labor, meaning that the goods that you produce is as a result of the capital and labor that you have, right? So Q is the dependent variable, which is output, while K and L are the independent variables, okay, or we usually refer to them as regressors. Okay, K is capital, L is labor. And I said the simple explanation of this equation here is that output is a function of capital and labor. Output is a function of capital and labor. Guys, is it clear?
Yes.
Okay. So I want to ask a question. What is the difference between short run and the long run? What is the difference between the short run and the long run? What is the difference between the short run and the long run? Does anybody want to answer that? What is the difference between the short run and the long run? Gary, what is the difference between the short run and the long run? Okay, yeah. Gary, yes, I'm listening.
Yes, you said short run production has at least one input.
One input, one fixed input.
One fixed input.
Okay. So you have one fixed input and one input that is a variable. Usually capital, like machines, are fixed in the short run. You can't easily change them. And things like labor, those are in the short run varies. You can easily employ more labor easily in the short run. Okay, Gary, what about long run? What about the long run? So if short run has a combination of fixed input and an input that varies. What about the long run? Who wants to answer that? What about the long run? Yes, anybody? What about the long run? I'm waiting. Yes, anybody? Yeah.
Yeah, I think it focus on fixing input, right?
No, so in the long run, you have all factors of production varies in the long run. Okay, in the short run, you can easily, in the short run, one is fixed and one varies. In the long run, all factors of production varies, meaning that both capital and labor can be changed at any time. Okay, both capital and labor can be changed at any time in the long run. Okay, in the short run, no. Capital is fixed, labor varies. In the long run, capital and labor varies. You can change them at any time. Okay, so is that differentiation, is it clear? Is that differences, is it clear? Yes?
Yes, sir.
Okay, good. All right, so and that explains it here. It says short run and long run. In bracket, that we usually refer to them as decision time frames. Short run refers to a period of time during which the supply and the use of certain inputs, plant, building, and machinery is fixed, while some will vary. Okay, supply of labor is a variable, while that of capital is fixed. In the long run, all inputs are variables. It is a period when a firm can change its plans, okay, just like I explained. To increase output in the short run, a firm must increase the quantity of labor employed. We describe the relationship between output and the quantity of labor employed by using three related concepts: total product, marginal product, and average product. So total product is the maximum output that a given quantity of labor can produce. Marginal product is the additional output that an additional labor can produce. It says the marginal product of labor is the increase in total product that results from 1 unit increase in the quantity of labor employed. So additional output you get from the additional input that you have employed or used. An average product simply is the total product divided by quantity, okay? Example, look at this table. On this table, you are being given total product. I don't know if I've taught you guys. Can anyone remember how do we get the marginal product? Do you know how to get the marginal product? So for marginal product, simply will be changes in total product divided by changes in the number of workers. So let's look at the first one. Number one, when the number of workers is 1, the marginal product is 24. 24, you put dash. Either you put dash or you put 24. Okay, when the number of workers equals 2, what is the marginal product? That is 72 minus 24 divided by 2 minus 1. Okay, you get 48. When the number of workers is 3, that will be 66 minus 48. So 66, and remember the formula is changes in, 133 minus 72. Sorry for that. 133 minus 72 divided by 3 minus 2. Okay, you are going to get 66. Okay? If we look at when the number of workers is 4, that will be 216 minus 138 divided by 4 minus 3. You can see my lighting 216 minus 138 divided by 4 minus 3 divided by 4 minus 3. Okay. So if we do the same thing for 5, that's 300 minus 216 divided by 5 minus 4. That's how you get your marginal product. And how do we get our average product? Remember, I said total product divided by number of workers. So 24 divided by 1, 24. 72 divided by 2, 36. 138 divided by 3, 46. 216 divided by 4, 54. 300 divided by 5, 60. 384 divided by 6, 64. And like that, like that. Is it clear, guys? Is that aspect clear to you guys, how I found the marginal product and the average product? Is it clear?
Yes, sir.
All right. Yeah, so I moved to a very important aspect. You remember that in the theory of consumer behavior, we did things like indifference curve, budget line. We also have the same for the theory of, under the theory of production, but this time around, the indifference curve for theory of production is called isoquant, while the budget line is known as isocost. Okay, so it's just the same concept we have done in the theory of production, in the theory of consumer behavior, but this time around, it relates to the theory of production. Okay, Gary, can you read this paragraph for me? Read this paragraph for me. Read it out.
Okay. It was derived from the Greek word ESO means equal, and Greek word quantos means quantity. The isoquant curve is known as equal product curve and prediction indifference curve.
So, yeah, I'm listening. Go on. Go on.
An isoquant curve is locus of points representing the various combination of two inputs, capital and labor, yielding the same output.
Okay, if you remember, indifference curve, we define it as a combination of two goods that yields the same level of satisfaction. But this time around, for an isoquant, is the combination of two inputs that yield, for indifference curve, combination of two goods that give the same level of satisfaction. For isoquant is combination of two inputs that yields the same level of output. Okay, combination of two inputs that yield the same level of output, and you can see that here. Okay, just like our indifference curve, you can see that isoquant is downward sloping. Okay, an isoquant is downward sloping. You see that? Then the rate at which one input or factor can be substituted for another is called marginal rate of technical substitution. Who can remember that of indifference curve? The rate at which you substitute one good for another for indifference curve. What did we call it? The rate at which you substitute one good for another. What did we call it? For indifference curves. The rate at which we substitute one good for another. What do we call it?
Substitution effect.
No, it's marginal what? Marginal what? It's
Marginal
called marginal what? Tell me. Marginal rate of substitution. Okay. Marginal rate of substitution. Marginal rate of substitution. But for theory of production, we call it the marginal rate of technical substitution. It's the rate at which we substitute one input for another. And those inputs are, you can see them capital and label. So this means that what did we call the slope of the indifference curve? So the slope of the indifference curve, you remember I said is the marginal rate of substitution. And the slope of the isoquant is the marginal rate of technical substitution. Okay. This means that the slope of the isoquant is the MRTS, marginal rate of technical substitution. This concept is significant in production analysis. An isoquant map, therefore, is the combination of more than one isoquant curve. Just like you have indifference curve, these are the characteristics of an isoquant. Negative slope, converge to the origin, cannot intersect one another. It indicates higher level of output. Now let's take a look at isocost. The isocost line shows the different combination of factor inputs which can be purchased with a given budget. Although similar to the budget constraint in consumer theory, the use of the isocost line pertains to cost minimization in production as opposed to utility maximization. So you could see capital labor, you could see all the points. Can you tell me from all those points, A, B, C, D, E, and inwards, what does that mean? For all the points, A, B, C, D, E, and inwards, where you have affordable, what does it mean? What does it mean? Okay, I'm listening. What does it mean? Points A, B, C, D, E, and inwards. What does it refer to? What does that mean on the graph? Who wants to answer us? Okay, I'm waiting for someone to give us the answer. Points A, B, C, D, E, and inwards on the graph. What does that mean? Carcass, what does it mean? Messis, what does it mean? Gary, what does it refer to?
Is it maximum utility point E?
Yeah, so A, B, C, D, E, and inwards simply means the inputs you can afford. For example, if you have $10,000 to hire labor and buy machines, the point A, B, C, D, E, and inwards where you have affordable is your total of your $10,000. So you remember that when we try to define the budget line, we say the combination of goods that you can afford based on income and price. But this time around, for the ISO cost is the combination of inputs, the inputs that you can be able to buy. Okay, that means that if you have 10,000 to start up a company, some of those part of that 10,000 will go to capital, and part of that 10,000 will go to labor. You cannot spend more than that 10,000, meaning that anything above your 10,000 is unaffordable. So it's just trying to tell you the amount of capital and labor that you can purchase. Okay, the amount of capital that you can purchase. Okay. All right. So one thing about the ISO cost line is majorly talks about cost minimization. Okay. And what is the point of cost minimization? The point of cost minimization is that point where the isoquant is tangent to the ISO cost. Okay, the isoquant is tangent to ISO cost. Remember, for indifference curves and budget line, we usually say at what point is the consumer most satisfied? The consumer is most satisfied at the point where indifference curve is tangent to the budget line. We also have that of production. At what point does a firm minimize cost the most? The point at which the isoquant is tangent to the ISO cost. Okay, the point at which the isoquant is tangent to the ISO cost. The point at which the isoquant is tangent to the ISO cost. Okay, so the point of cost minimization in the theory of production is the point where the isoquant is tangent to the ISO cost. Is this clear? Is it clear, guys?
Yes.
Okay, Gary, is it clear?
Yes, sir.
Okay. So now we move it to laws of returns to scale and we'll call it a day. So remember short-run laws and long-run laws. Who can remind us what are the differences between the two, short-run and long-run? What are the major differences between the two? What are the major differences between the two? Can anybody remember? Short run and long run. What are the major differences? Okay, I'm sure you already know that. Let's move on. So laws of returns to scale, this shows how output will respond as capital and labor input changes. When a firm increases all its input proportionately, there are three possibilities: constant returns to scale, increasing returns to scale, and decreasing returns to scale. For constant returns to scale, an increase in total output is proportional to increase in input. That is, if inputs are doubled, output is doubled also. Output equals input. That's constant returns to scale. What about increasing returns to scale? An increase in total output is greater than proportional increase in input, which means output is greater than input. What about decreasing returns to scale? An increase in total output is less than proportional increase in input. So it means output is greater than an input. For the first one, constant returns to scale, what that is saying is that, for example, if you hire more labor, for example, you already know the given output those two laborers will be able to produce. So if you hire labor like 2 people, I know that those 2 people would be able to produce 5 shoes, for example. Maybe those 2 input is proportional to those 5 shoes, then that's a constant return scale. However, if you expect that those 2 laborers that you employ, you already know they are meant to produce 5 shoes. If they produce more than those 5 shoes, maybe they had to go beyond their capacity. They had to use new forms of technology. They had to use that time efficiently. They had to use, they were so productive that they produced more than 5 shoes, then that is increasing returns to scale. However, if you expect them to be productive and those 2 employers, although they are meant to produce about 5 shoes, if they are producing 2 shoes, it means that they are performing below expectation. Therefore, we can call that decreasing returns to scale. So constant returns to scale is proportional. Input and output, if you double input, of course, you have the same expected given output. For increasing returns to scale, if you double input, you would have more output. Okay? You would have more output maybe as a result of the kind of technology that you use, maybe as a result of you brought in a new manager, maybe as a result of you moved to a new office, maybe as a result of that you have more access to electricity, maybe as a result of you had to bring in more new board members, maybe as a result of you had to bring in new investors or investments, right? There are so many factors that are responsible for increasing returns to scale. Increasing returns to scale simply means that you are performing above expectation, above, meaning that you are producing more goods as expected. And there are so many factors responsible for that. Why decreasing returns to scale is when someone is performing below expectation. And also there are so many, or when a firm is producing less than what it should be producing. And there are so many factors that are also responsible for that, okay? So review questions, explain the concept of isoquant and isocost, and explain the laws of returns to scale. Okay, so do we have any questions? Any questions? Do we have any questions?
No.
Do you have any questions? Yes, no? Okay, if there are no questions, we can call it a day, okay? I have put your first assignment. Please go and check it. Have you seen your first assignment?
Yes, Doctor.
Yes,
okay.
Professor.
Okay, so you should, I'll also put the second one very soon. Maybe by weekend, I'll put the second assignment, okay? So please do your assignments to the best of your knowledge. Do them very well. I'm going to put the second assignment latest by weekend so that you can start working on that also. I think in total, we will have about 3 to 4 assignments, okay? And I might get to use everything, all right? So I wish you guys a productive week. Study very well, study very hard. Okay, Fatima, yes.
Professor, I have a question.
Yes, Ryder.
Because I didn't get to ask you this before. Will we take a midterm or is it only going to be a final?
It's just final exams.
Do you have any idea when it's going to be?
If you check, I put the details on Uzebim. Did you see that?
It says from 7 till 17, I guess.
Yeah, 7 to 17th.
Yeah, I'm pretty
12
sure.
to 12 to 19.
12 to 17.
12 to, oh, okay.
Okay, any of those dates. Just know that your exam will be between any of those dates.
Okay, thank you
I don't
so
know
much,
the exact
Professor.
dates now. It could be any of our class hours, either on Tuesdays or on Thursdays. Okay, it could be any of those.
Okay, thank
But
you.
once I'm sure of what that exact day will be, I'll let you. But just have it in mind, it will be between August 12 and 17, and it might be during our class hours. Okay.
Okay, thank you.
You're welcome. All right, guys. I'll see you next week. Okay, I'll put your second assignment by weekend, latest by weekend. Okay.
Okay, doctor. Thank you.
All right. Have a great day. Bye-bye.
Great day.